Okay, now we're going to cover the automatic processor, so automatic processing. So it's a complex system. It has several subsystems within the processor. So there's the transport system, the dryer system, the replenishment system, the circulation system, and the temperature control system. You'll need to know what each system does. So with the transport system, it's the largest and most complex system. It moves the film through the developer, fixer, wash, and the dryer. It's made up of a lot of moving parts and it breaks down all the time. So there's three subsystems within the transport system. There's the roller system, the crossover network or transport rack subsystem, and the drive system. So with the roller system, there's entrance rollers. It's found on the entrance for the racks. The transport or planetary rollers, it's the most numerous, and there's the master or solar rollers, which are the largest, and I'll show you examples of those. So the crossover networks or transport rack systems, so the entrance rack, which is at the feed tray, so where you put the film down to enter the processor into the developer. There's guides to ensure the film is straight, so you're always going to put the film in with short access and up against the guide so it goes into the processor straight. The tanks are vertical and they're deep, and the racks go within. So we talked about with the developer, it doesn't like to be exposed to air, so that's why they're vertical and they're deep and they're narrow. So this, it controls the time going through the developer and the fixer. The turnaround racks are used at the top and the bottom. They're like guides to make the sharp turns. So the crossover racks, they have to be cleaned before use every day, especially if they sit above and are exposed to air. So the drive systems, it's a series of mechanical devices designed to turn the numerous rollers in the processor. It's a single motor. It's usually between 45 and 120 seconds, and it controls the time the film is in the chemicals. So here's an example of a automatic processor. So here's the feed tray, and there's usually a micro switch that when it hits, the film hits the micro switch, it turns on the processor, and the rollers and the motors and everything kick on. So you come down, and here's your large rollers there. These are all your small rollers. There's a crossover rack at the bottom, there's a crossover rack at the top to guide the film through these sharp turns. So here's your developer, here's your fixer, here's your wash, and then here's your drying system right here. So the drying system is your final stage. It consists of 2 to 3 heating units between 1500 and 2500 watts. They use 60 to 80% of all electrical power for the processor, and air is blown through a series of air tubes to increase the velocity of air. So the temperature is between 120 and 150 degrees, and it's at high velocity to dry the film. The replenishment system, and also known as the regeneration system, is used to replenish the developer and fixer. So there's different types. There's volume replenishment, flood replenishment, timed or standby replenishment, and standby switch. So it consists of pumps, storage tanks, and plastic tubing for this replenishment system. So the main two options are the volume replenishment, which replenishes each time a film enters the processor. There's flood replenishment, which pumps are controlled by a timer. Both methods, replenishment, which is more fixer than developer. Circulation, also known as recirculation or filtration system, it stabilizes the temperature, agitates the solution, mixes the chemistry, and filters the solution. So it draws chemistry from the bottom and refills it on the top. So the fixer has a mesh screen because it can get thick towards the bottom. You don't want to get thick stuff going through to the silver recovery unit, and the fixer is considered toxic with silver, and it cannot be dumped down the drain. It has to go to a silver recovery unit, which you'll cover next. The temperature control system, it regulates the solution temperature. So water's controlled system uses temperature of the wash water to regulate the solution temperatures. So it's regulated through the wash and controls the rest of the processor through that. Thermostatically controlled, called a heat exchanger, is the most common. It consists of heating coils that are thermostatically controlled, and the processors only require cold water coming in. The electrical system distributes electrical power and monitors the operation of other systems, usually consists of solid-state microprocessor circuits. Some models can actually perform many quality control functions, which is great. So there's different types of automatic processors. Back in the old days, there's a 7-minute processor that was fast, I remember. We went to the 3-minute processor, which is great. Then the 90-second, 60-second, and there's a 45-second processor. There's also multi-speed processors where the transport system speed can be varied to dependent on the different chemicals and film combinations. So processor size, there's the floor size, they're the biggest, used for high volume processing conditions, so like large hospitals. Intermediate, so in between size, found in smaller clinics and physician's office, and then there's the table and countertop size, that's the smallest, it's used in small dark rooms like ours. So there's different processors depending on where they're located. So there's the totally inside the darkroom processor. It's not sealed, it's not lightproof. There's the bulk inside darkroom where most of it is on the inside of the darkroom. So if usually it's just the drying portion is on the outside. So if there's a problem with the film getting stuck in the processor, we can just go into the darkroom and pull it out without being exposed to any light. There's the bulk outside the darkroom, and there's the total outside darkroom, which is most often called the daylight processors. So cleaning of these processors, we had to do this all the time, and it was a lot of work. So with your quality control, daily we had to rinse the crossover racks, rinse the deep racks, observe transport system during operation, observe solution levels in the tank, and rinse and remove crossover racks at shutdown. So we'd always have to take them out, rinse them off. Monthly, we drain and wash all processor tanks, re-rinse with water and refill with fresh solution, add starter solution if needed. Quarterly, drain and wash replenishment tanks, refill tanks, fresh solution, and check the specific gravity. And yearly, we thoroughly do a cleaning. We take everything out, drain it all. We'd actually have someone come out. So processor maintenance, so there's scheduled maintenance, preventative maintenance, and non-scheduled maintenance, as you can imagine. So sensometric testing requires the following. So you need a sensitometer, create a step pattern on the film. A densitometer measures the optical density from the step from the sensitometer. And your base plus fog should not vary more than 0.05 for dual emulsion and 0.03 for single emulsion films. So speed or mid-density indicator, so the optical density of the step closest to 1 above base plus fog should not vary by more than plus or minus 0.15 from the accepted value. And feel free to talk to Jeremy about this. He will go through all the film, and I believe you've already done some testing of base plus fog. So quality control film. So the film used in the sensor when we're running strips is kept in a separate box, and we log the lot numbers and everything to make sure that it is the same. You can't use different film all the time, or else your values would be skewed. So when we get a new box, we have to run special strips to find the speed and everything, the base plus fog of the new film. So processor troubleshooting, it's in your book, so you can look at that and see. Most of you have never seen a processor. So daylight systems, they require same cleaning, maintenance, and monitoring as standard film processors. Film transport mechanisms require extra maintenance to keep films from jamming within the system. It's not fun when they do. So here's just a quick look at the processor controls. Quality control. It's really important that you take a look at your quality management book. In the quality management book, we have chapter 4, which is film processing, chapter 5, which is processor quality control, and chapter 6, which is your silver recovery. So those are the 3 chapters within your quality management book that you will want to take a look at, along with looking at your Carlton book on film processing, along with Bouchon. Okay,